Here's a circuit diagram we took from an RCA mixing console, the actual BC-3C consolette, and there was a USA version and a UK version in the early 60s, I think this one was. It's a 5AR4 model. There was a line version as well. This one's a mic version, the AR4, and it uses a 12AY7 vacuum tubes. There's two of them in there, and that's a double triode valve. Here's Phil Moss with the circuit diagram. He's going to take you through it all.
Here we have a fairly straightforward preamplifier. They don't show the actual input circuit here. As you can see on the left, it says external gain control, and then it goes into the grid of the first valve, the half of a 12AY7. Straightforward voltage amplifier. The only thing to note there perhaps is that there is negative feedback from the anode of the second half of that valve via what they call 1R5, which is a little bit of a confusing designation because it makes it sound like a 1.5 ohm resistor, but it's a 330k in series with a 0.022 microfarad back to the cathode of the first valve, which is therefore unbypassed, otherwise one wouldn't be applying any negative feedback. It's shown as a 1 watt resistor. It's not actually going to dissipate 1 watt in such a low value as 8,200 ohms in the cathode there. They've used a 1 watt resistor simply because it's lower noise than the smaller resistor would have been. This circuit predates by a long way metal film resistors. It's saying a 5%. It could have been that that actually is a carbon film rather than carbon composition. Interestingly, the anode load resistor, which must by definition dissipate approximately 12 times as much as the cathode because the same current is flowing through the two of them, but obviously the voltage will be in proportion, and that's about 12 times the 8.2k. That will get a lot warmer, but they're not showing it as a 1 watt and they're not showing it as a 5%. For best noise performance, really, that resistor needs to be a high stab. And if one was servicing one of these units, even if the resistor was on value, and presumably it's a 20% tolerance as it's not marked otherwise, I would certainly replace that with a metal film or a metal oxide, and I would use one at least half a watt. The second half of this, well, it's just a grid leak, an unbypassed cathode resistor. One might have thought they'd bypass that. It would increase the gain and it would also decouple the noise generated in that resistor. It then feeds out to the volume control, along there to the top of the volume control and back to the grid of the second stage. Now here we have a very strange situation. Unless there is a missing decimal place there, 1.6k sounds more rational than 16k to me by a very long way. Funnily enough, this is marked as 5%, whereas they didn't bother with the previous two anode load resistors. That is the one I've talked about considerably there, the 100k, or this one here. Oh no, that is a 5%, sorry. But the anode load itself, the feedback they've got relatively close tolerance, because if they don't do that, then the gain of the stage will be affected. As far as the gain setting is concerned, it's that resistor and that resistor which set the gain of the amplifier, except at very low frequencies where the reactance of this capacitor needs to be taken into account. Now, going back to where I was, we've got a very high value there of anode load, the 220k there, so we get more gain out of this valve, one would think, than the previous two with their lower anode load resistors. This is designed to have a high impedance output and a low impedance output. So we only need a small capacitor there because the input impedance of this grid is the amplification factor of the valve as you would expect it to be, times the value of this resistor here approximately. So if this was even just a times 10 with 56k, that will be about half a meg input, which is fairly low. If this were a 12AX7 running at times 100, however, that would make that 100 times greater, which is 5.6 megs, isn't it? 56, yes, 5.6 meg. Excuse me whilst I do slow mental arithmetic. This will somewhat reduce the multiplication factor of that resistor, and the gain of this valve is probably more like somewhere between 20 and 50. But the point that I'm making is this is still a much higher input impedance, and it multiplies that resistor too. So virtually an electrostatic input there. That resistor there is purely to leak the DC so that when you plug into it there isn't a great big thump as this capacitor charges up to the fairly high voltage on that cathode. For some reason they have chosen an output impedance of 3.3k. One might have expected them to aim for about 600 ohms, which is what they would get if there was no resistor there. So this is a low impedance output. Now here we have two HT supplies, but it's a little bit strange. They've only got 10 volts between them. I think in reality it isn't the precise voltage that matters. I think you would find if you saw the power supply that there is simply a decoupling resistor between that supply, and also somewhere externally there is a decoupling capacitor from there to earth. The heaters, as with many of the double triodes, we know them as ECC 81s to 83, they are centre tapped, so you can either run them on 12.6 volts at 0.15 amps with the heaters in series, or you can parallel the halves and run them at 6.3 volts at 0.3 of an amp. Here they have chosen to do the latter. Depends entirely on what is convenient for the circuitry. For most purposes you'll see them used this way around with 6.3 volts, which matches most of the other valves they're likely to be used with, like EF86s, and in a power amplifier valves like EL84 or old valves like 6V6s. Most of the valves used for AC only equipment were 6.3 volts. If you were running it off batteries, however, you might choose to run them at the 12.6 volts to represent a 12 volts lead acid battery. Okay, I think that's that.
If you found this tutorial very useful and would like to see more, then please subscribe to our YouTube channel, Patreon, Facebook and Twitter accounts. So far to date we have covered dozens of vintage valve amplifiers and equipment, starting with basic items such as Danset, Bush and Philips record players. We've also covered the Mullard 3.3 and the 510 valve amplifiers, the mic amp and mixer circuit based around the EF86, the Hacker and Dynatron record players, Leak TL10, quad valve amplifiers, GEC MOV division, Radford, Pi, Dynaco Stereo 70 and many other British and foreign audio circuits. We are in the process of shooting lots more videos on a regular basis and we will be uploading often. We cover hi-fi, musicians and recording studio equipment as well as vintage radio circuits. Please go to the website for more details.